one-to-one functions. So I'll read the definition and then we'll kind of break it down into pieces. It says that a function f is one-to-one when for a and b in its domain, f of a equals f of b implies that a equals b. So let's take a look and see what that even means. We're going to do this f of x function right here. Is the f of x function one-to-one? We are trying to do the f of a equals f of b implies that a equals b. This means I'm going to start by subbing the a into my function. So instead of the square root of x plus 1, I have the square root of a plus 1. We're going to see what happens when I sub in a b. So now it's the square root of b plus 1. Again, I had f of a, I subbed in an a in for x, and then I had an f of b, and I subbed in a b in for my x. So to simplify, I'm going to subtract 1 on both sides. Now I'm going to square both sides. A square root squared, those are inverses, totally undo each other. I am down to a equals b. So good, I got what was needed for a one-to-one function. So yes, this is a one-to-one function. Now graphically, let's see what that means graphically. I'm going to read the horizontal line test here. The horizontal line test is one way to use a graph to tell whether a function of x is one-to-one. If every horizontal line intersects the graph of the function at most once, then it is a one-to-one function. So I'm going to graph this square root of x plus 1. It's like my square root function shifted up 1. So instead of 0, 0, it hits the point 0, 1. Instead of 1, 1, it hits the point 1, 2. And instead of 4, 2, it hits the point 4, 3. So this square root function got shifted up 1. Here's my f of x that they gave us. Now we are going to do a horizontal line test. So as I draw one horizontal line, let's see if it intersects any more than one point. No, it only hits once. Next up, another horizontal line. That one also only hits once. And another one also only hits once. I'm going to actually slide this up and down to see if it will ever hit more than once. And it looks like it hits 0 and 1 point, but it never hits 2 points, which means that I actually get the same answer graphically. I can tell that yes, this is a function. Some of them algebraically is much more difficult and graphically is a bit easier. So let's look at the next one. It says, is the function h of x equals x squared minus x one-to-one? And probably the best way to approach this one would be graphically. So there are a couple ways to graph it. You can do an xy chart. I'll sub in a few numbers here. -2 subbed in gives me a -2 squared minus a -2. So it's like 4 plus 2, so 6. At -1, I get -1 squared minus a -1. So I get a 1 plus 1 is 2. When I sub in a 0, I get 0. When I sub in a positive 1, I get 1 squared minus 1. So I get 0 again, which this is kind of a hint for us right now, but let's graph it. -2, 6. -1, 2. 0, 0. 1, 0. And this is probably going to be symmetric. I'll probably hit over at the 2, 2 and 3, 6. So here's my h of x function. Now if I draw another horizontal line, because I'm doing the graph, I want to test it with a horizontal line, I'm trying to see if it will ever hit more than 1 point. And I mean ever. If it happens just once, then it's not a one-to-one function. This one actually happens multiple times. So I can tell that this one, no, it is not a one-to-one function. So the one function above, yes, it is a one-to-one function. The second one is not a one-to-one function. Okay, I hope that helps with the horizontal line test.